the first example of uniform distribution. All right, let me move the screen a little bit. So let's take a look at the problem. So the first one is answering a quiz question. Suppose a multiple choice quiz question can be answered in 60 seconds. The time follows uniform distribution. So the word in 60 seconds, that tells me A is equals to 0, B is equals to 60. So we have a minimum and a maximum. In part A, I can quickly determine the probability density function, the PDF, that is B minus A. So that is 1 divided by 60. And then here is the graph that x is between 0 and 60. So we have a point at 0, we have a point at 60. So since the slope is 0, we have a horizontal line. And then the height of this rectangle is 1 over 60. And then what is the domain? The domain is x is between 0 and 60, including these two numbers. What is the area of this rectangle? Then the area is the base, which is 60 minus 0. And then the height is 1 over 60. So that is equals to 1. And then this area is equals to 1. All right, so that would be the setup for these problems. And then the graph is very important. We will have to use the graph over and over again. Okay, let's move on to part B. In part B, we have expected value. So we write the formula 1/2 times A plus B. So let me make the screen smaller so I can have more space to write. And then 1/2 A plus B. So that is 1/2. We have 0 plus 60. That is equals to 30 minutes. So that means on average, a student can answer a quiz question in 30 minutes. I mean 30 seconds, not minutes. So let's erase that. Change that to a second, as easy. And then the next one is variance. So that is 1 over 12. This 1 over 12 is built in the formula. It's always 1 over 12. You cannot use any other numbers, all right? Always 1 over 12. You have a B minus A, which is a 60 minus 0 square. So this one is equals to 300, but the unit is second square because you square the seconds, which makes no sense, right? You cannot square units by seconds, right? What is square second? Is that means I have a lot of time? Nope, it makes no sense. And then the standard deviation is the square root of 300. This one you have to round a little bit. I will say keeping one decimal place is enough, 17.2 seconds. All right, so that is the basic setup of a uniform distribution problem. In part C, we have to solve the very first probability question. What is the probability that the quiz question can be answered in at most 27 seconds? Again, at most 27. That is x less than or equal to 27. The maximum is 27. All right, draw a graph. From 0 to 60, the height is 1 over 60. Okay, I just replicate the graph one more time. Where is 27? 27, I assume 27 is right here. Less than or equal to, then this is my area. The question is asking, what is the area of the shaded region, which is the base times height. Now you have to use your geometry. The base is always the big number minus small number because you cannot use small minus big. Probability cannot be negative. And then 1 over 60. So you have 27 divided by 60. In most cases, this can be your answer. You don't really have to simplify the fraction because this is a probability question. This question is not about simplifying a fractions. Or you can take 27 divided by 60. That equals to 0.45. That is how you answer a uniform distribution question. With lost practice, you can answer the question without sketching the graph. But at this point, I highly recommend you to do the graph. And then part D, what is the probability that the quiz question can be answered in at least 45 seconds? At least 45. So that means 45 or above, greater than or equal to 45. So let's draw a same graph. I know it's annoying. Please do it. You don't have to use a solid line. Use a dashed line is fine. But if you use a solid line, I don't think you will lose points for that. So 45, this is 45 greater than or equal to, then that is equals to 60 minus 45 times 1 over 60. So that is a 15 over 60. Do this in your calculator. You can quickly find out that that is 25%. All right, box your final answer. Show all your work. The next question is no more than 25. All right, so E is no more than 25. So the opposite of more than is less than or equal to. Do the graphs. You can pause the video at any time to do the work yourself. And then after you're done, you can resume and then check your answer. Okay, 25. So that is 25 minus 0 times 1 over 60. That is around approximately 0.42. Okay, and then part F is no less than 34. So that is probability. The opposite of less than is greater than or equal to 34. Now, I am going to answer a question. If I remove the equal, does that affect the answer? We will find out in a minute. All right, from 0 to 60, we draw a graph. Here is my rectangle, 1 over 60, 34, greater than 34. Okay, so that is my area. What is the area? The area is 60 minus 34 times the height. So we have 26 divided by 60. That is around 0.43. Is the equal important? The answer is not, because x is a continuous random variable. Think about this. If you don't take the 34, what number do you take? Nothing. You have to take the 34. Okay? 30, even though you remove the equal, it doesn't affect the answer because x is a continuous random variable. All right? So moving on to part G, the quiz question can be answered in between 20 and 40 seconds. Is the inclusive or exclusive important? I just answered that. So part G, we have 20 x 40. So from 0 to 60, this is 1 over 60. We have that. 20, 40. Using dashed line is fine, solid line is fine, because what we really need to see is the shading region. Okay, what's the area? The area is 40 minus 20 times 1 over 60. So this is 1/3, right? 20 divided by 60, 1/3. So that is 0.3333333. A bunch of 3. Is the equal important? The answer is not important. The reason is x is a continuous random variable. That's why the equal sign is not important. Moving on to something more complicated, we have a conditional probability. Let's take a look at this. Part H. Suppose a student has spent 15 seconds on a question, but the question is not solved. Find the probability that the quiz question can be answered in the next 23 seconds. This is a conditional probability. We have to change the PDF a little bit. All right, so let's write the probability notation. We have part H, the probability given has spent 15 seconds, right? This is greater than or equal to 15. You just spent 15 seconds on it. The question is not solved. So you are still thinking. The clock is still ticking, right? So it's more than 15 seconds. You are still thinking, right? You are still using time. So the clock is ticking. So that's why it's greater than, not less than. And then what is next 23 seconds mean? Next 23 means you just have to add a 23 to it. So 15 times 23, that equals to 38. So this is x. X what? X less than or equal to 38. All right, let's draw the graph from 0 to 60. And then here is my rectangle. Do not put the height yet. We have to change the PDF. That is so important. I am going to do this in red. So this is a conditional probability. We have to change the PDF from what to what. It is f of x. The highest is still 60. Since that is a 15, so we have a 15 right here. The minimum is now 15 minus 15, that equals to 1 over 45. This is 1 over 45 now. It's no longer 1 over 60. I already know that x is greater than or equal to 15. So I don't care the space between 0 and 15. So that's the reason. And then you add 23 to it. Let me change back to blue. So you add 23 to it, then you stop at 38. So this is the area that we are looking for. What's the answer? The answer is when you find the answer, once you get the area, the problem is pretty much done. You are looking for the area of this region, which is the base, times the height. So that is equals to 23 divided by 45. That is around 0.51. So that is H. And then part I, given that a student has spent more than 20 seconds on the question, but the question is not solved, find the probability that the quiz question can be answered in more than 50 seconds in a 60-second time window. All right? Probability given x is greater than or equal to 20. Again, the student is thinking the question is not solved yet. So in more than 50 seconds, so x greater than 50. This just got interesting. We have to change the PDF, I know. We draw the graph first. From 0 to 60. And then the minimum is 20, right? And then greater than 50. This is 50, right? Greater than 50 is here. What do you see? They are actually independent, right? Because to find x greater than 50, I don't need to know that x is greater than or equal to 20, because greater than 50 already cover greater than 20. Think about this. A number that is greater than 50, that number has to be greater than 20, right? Because 50 itself is greater than 20. How do you change the PDF? We do this in another color. Change the PDF. So you have f of x equals to 1 divided by the maximum minus what? Minus the given. Always, again, minus the given. 20. So that is 1 over 40. Always subtract the given. 1 over 40. Do not subtract the 50. Okay, what's the probability? Going back to blue, the probability is just this area. When you look for a probability, I am looking at this area. I don't care the stuff that you wrote in somewhere else. What is the area of this rectangle? The answer is 60 minus 50 times 1 over 40. Then you have 10 over 40. That is a quarter, right? 0.25. That is your answer. All right, we have two problems left. Three problems left. In part J, find the 20th percentile. The 20th percentile. What does that mean? So part J, the 20th percentile. 20th percentile. Let's draw the graph first. From 0 to 60. We have 1 over 60. Again, this is not a conditional probability. It is okay to use the 60. 20th percentile. Remember what Q1 is? In your box plot, Q1 is the 25th percentile, the first 25% of the data. This is 20%. 20% means I am going to cut 20% on the left side. Another way to say this is the first 20%. So I'm going to put an unknown K. You can use J or whatever letter you use, because I have been using K for a long time. I get used to it, so I will be using K. The question is asking, what is K? So to answer that question, tell me, how do you find the 20%, the area? You take the maximum, K, minus a minimum 0, times the height. That equals to 20%, right? Solve for K. So we multiply 60 on both sides. K is equals to 0.20 times 60. K is equals to 12. That is the answer that I am looking for. What does that mean? That means this is a 12, right? The probability that the student can answer a quiz question in the first 12 seconds from 0 to 12 is 20%. From 0 to 12 seconds, what is the probability that the student can answer that quiz question? 20%. Part K is upper 45. K is upper 45. So K is upper. Upper means right hand side. So we do this from 0 to 60. Cut 45% on the right, then this is K. Okay, how do we solve that? We have 60 minus K times 1 over 60. That equals to 0.45. That's how you do it. And then solve for X. So first we multiply this 60 on both sides. So 60 minus K equals to 0.45 times 60. And then 60 minus K is equals to 27. And then K is 60 minus 27. K is equals to 23. 23. I wrote 22. Actually, not 23. Bad math. 33 minute. Oh, not minutes, seconds. So this is a 33. There are two ways to explain this. The first way to explain this is the probability that a student can answer a quiz question in 33 to 60 seconds is 45%. Or you can calculate the time window. How much time do you have between 33 and 60? 60 minus 33 is equals to 27. Another way to explain this is the probability that a student can answer a quiz question in the last 27 seconds is 45%. All right, moving on to L. So L is the middle 50%. So middle 50%, we have that. From 0 to 60, we cut 50% right in the middle. That gives me a big problem. That big problem is this is a J, this is a K. We have two unknowns. What do I mean by two unknowns? When you solve an equation, you take k minus j times 1 over 60 equals to 50%. This is not solvable. You multiply 60 on both sides, that is not solvable. I mean, you multiply 60 on both sides, that is not solvable. I am not able to solve one equation with two unknowns. Then what can I do? I need this and this. How much are those? You take 100%, which is the entire rectangle, minus 50 divided by 2, that equals to 25, right? So I have 25% in here and there. And then using this, I am able to find my j and k. So let's find j. J is, you have j minus 0 times the height equals to 0.25. K is, you have 60 minus k, again, always big minus small. 1 over 60, that equals to 0.25. And then 60% times 0.25, j minus 0 is 15, right? 0.25 times 60, that is equals to 15, so j is equals to 15. This is 60 minus k, 0.25 times 60, that is equals to 15, so k is 60 minus 15, that is equals to 45, so that is j, that is k. How do we explain this? The unit is in second, not in minute. Second, okay? Not in minute. The probability that a student can answer a quiz question between 15 and 45 seconds is 50%. So that's all for the first example problem. I will show you the second example problem in the next video.